We were upstairs. We heard a noise, and we came down. We saw a man, a big man.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Peter Evans, who is the CEO of Patriot One Technologies, which is a global leader in threat detection. Welcome to the show.
Thank you so much, Scott. Pleased to be here.
All right. So we were just sharing that you had joined Patriot One within the last month or so. But of course, your background is pretty extensive in terms of VC as well as running enterprise companies. Can you tell us a little bit about some of the work that you've done and how that ties into what Patriot One is doing, especially as it pertains to new horizontal capabilities such as AI, ML, and DL?
Yeah, absolutely. So thank you so much, Scott. It's wonderful to be here today. My background, has varied in my career through, telecom, cybersecurity, and most recently with companies that are doing a lot of work in kind of SaaS-based delivery models and looking at things like AI to reinvent, certain vertical industries and applications. What led me to Patriot One initially was, a conversation with a gentleman telling me about where their business model was, but more importantly, where it was going. And what struck me when I looked at Patriot One was there was a uniqueness in how they were approaching the AI problems versus other AI companies that I've worked with, and I've probably worked with a couple of dozen in my career. Patriot One has done a very interesting thing to build a very horizontal platform that can take multiple sensor inputs and sources of data, leverage multiple machine learning engines as opposed to just one that's custom built for a certain application to create a high degree of efficacy around actionable intelligence to provide to humans. As we know, when you look at things, humans are very good at making decisions around small sets of data. Well, they can be overwhelmed by very, very large sets of data. And oftentimes, AI machines are intended to take a lot of data and crunch that down to something that's actionable. But what I've seen in the industry and what I thought was very unique with Patriot One, and so why I wanted to kind of join this journey, was Patriot One's taken a bit of a different approach to those machines, right? It's not just one AI engine that's purpose built for a certain application. They're actually built, again, multiple machine learning engines that then correlate their insights to provide a much higher degree of efficacy and accuracy in the outputs they provide. And with those multiple engines, you actually become much more context aware. And what do I mean by that? Well, a lot of AI applications that you see in the marketplace, say things like facial recognition technologies, really haven't taken off, in a broad market way. And because they work well in a lab environment, or they work well under a certain set of conditions with a certain set of inputs, but they don't work well when you start to put them out in the real world, where you might have complexity, you might have clutter, you might have people, you might have weather, you might have environmental conditions, and things like that can distort the insights. By correlating across multiple inputs with multiple machine learning engines, you create a much higher degree of validation of the information. So I thought, this is a very interesting AI platform that can be both applied horizontally as well as vertically with captured data and vertical specific applications on top of the engine.
Well, thank you for that introduction. And I think and this was something that I think we've been forecasting for some time. I think in the last 10 years is this notion of multimodality that,
yes,
especially as IoT and sensor capabilities allow for captures of thermal, heat, sound, vision, to even chemical and compounds and biomarkers,
Agreed.
The ability to be able to actually overlap and look for those convergence. And to your point, it's trying to cut out the noise factor in terms of signal processing and get down to some degree of confidence. And because you're looking at it from a different modality perspective, you could start to overlayer that and have this kind of a, apex and a lens filter perspective that a single dimensional perspective would probably not do a great justice.
Yeah, exactly.
I want to kind of go back to the original a little bit about the company. I know the company has been around for some time. I believe the initial goal, according to what's stated, was that it was really leveraging Dr. Natalia Nikolova's research in terms of the high frequency using electromagnetics to be able to actually detect metal objects such as concealed guns and knives, utilizing that microwave radar technology. But over the years, again, I know that you're, kind of coming on board, but over the year, how has that evolved to add additional modalities that we're talking about, including, I think, looking at your product portfolio, the inclusion of computer vision, that's really starting to look at things in a very interesting way. Can you talk about the evolution of the company based on what, the debriefing that you received and where the company is potentially going from here?
Absolutely. You're absolutely correct. There was an original innovation that came out of McMaster University around being able to detect covertly, and essentially the prime idea was around guns and weapons, knives and things like this. And, the idea was, can I get a better solution that can be non-obtrusive, be covert in its application, and have a high degree of accuracy without interrupting business flow? So if you think of how we protect against things like guns today in, whether it's a sports arena or, an airport or other environments, there's kind of a business interruption situation where people have to unload the metal out of their pockets, go through an x-ray machine and these sorts of things, and that has all sorts of challenges to a business. Simple example, I'm a sports stadium and I'm worried about letting folks come in, and statistics show in the 20 minutes before the first pitch of the baseball game, that's when 2/3 of your customers are actually coming to the stadium, and interrupting that flow, interrupting the experience, potentially interrupting people's civil rights or civil liberties, and kind of worrying about things like privacy. There was a lot of complexity in how things have been done today. So the idea was to use this innovation to actually detect guns non-obtrusively, not impacting the business flow. That's a very complex problem, particularly to try to do that at a distance in very, very cluttered environments where you might have laptops, iPhones, keys, all sorts of other metal objects, and making sure you're doing that with a very, very low false positive rate, right? Because the last thing you want to do is pull someone aside inadvertently. So that was sort of the genesis of, that solving that complex problem was the genesis of the AI platform that's been developed. And that solution is out in the marketplace today. And what we've been doing is continuing to refine it in order to get much higher accuracy and lower the false positives in very, very complex environments. Imagine an environment like a school where you've got 20 school kids walking in the front door, all with backpacks, and one of them may or may not have a gun. And you want to make sure that you're not, falsely pulling aside a child, and the clutter involved in things from binders to laptops. That platform, though, has got great extensibility. Simple example, in our COVID world today, we were able to very quickly turn on the platform and do a quick turn on some software, so we could do a lot of what other folks have been doing, but then pull it together into an integrated solution. So detecting thermal temperatures of individuals, detecting facial recognition and mask recognition, object recognition, counting occupancy, and not only doing that to count numbers of people, but validating that information with other insights and other sources of data to not only get a view of how many people are in this room, but how distant are they from each other. So there's all sorts of different signals you can think of, Wi-Fi signals, for example, cell phone signals, and getting that insight to provide a little bit more than a count, but actually intelligence about what's going on. That same platform has got all sorts of interesting extensibility, and we're testing right now healthcare applications, right? So a high degree of accuracy in terms of reporting on things like imagery for x-rays, right? Looking at flat files, looking at image files, looking at text files, looking at video files, I'm going to see a lot of different applications that we could quickly turn into to extend the platform into things like, if we're already doing security for guns, why not perimeter security and looking for break-ins, looking for breaking glass, looking for people going out, jumping perimeters, looking for behaviors, right, and detecting, is this two people dancing or is this two people fighting? Right. And so you can start to see crowd behaviors and look for those anomalous situations that are predictors of a problem. So, looking at, we can now predict things like fights, crowd disturbances, and things like that. So you start to get a very, very robust package to address a broad set of industries across the same AI platform.
So just to, I think, have some clear delineation and classification is that,
Sure.
First, I think we're talking about weapons in the sense of tangible physical weapons. And so let's take the example of guns, for instance. So, there is one dimension that's looking for kind of that metal detection.
Yes.
But the computer vision and then object detection algorithms are also starting to classify it that it's fitting into some sort of a gun shape based on the training that it's gone through, recognizes the difference between a handgun versus a semi-automatic or something to that extent. And same thing goes for knives and various other weapon classifications. So there's that kind of physical asset classification, object detection.
Yes.
The other piece that you're layering on is more behavioral. So the behavioral of, again, there's a lot of different labs and big tech that's been doing this is, so whether you're at a subway or large venue, are they friendly? Are they getting along? Or is this an actual fight? Is this a mugging? Is this a rape? Is this an assault? And being able to have enough contextual understanding to be able to flag it properly, so you're getting the right positive versus the false negatives that could really kind of blow up the system to some extent, have too much sensitivity.
Exactly.
Can you talk about the training aspects? Because you're dealing with a lot of different modalities. You're dealing with a lot of different situations and use cases, somebody jumping over a fence, somebody breaking a window. Mm-hmm. How do you go about training the data? How do you go about finding the right data set and then training it properly? And are you using a combination of supervised and unsupervised as well?
Yeah, it's a great question and great observation, Scott. You nailed it. You're exactly right. There's a difference between a gun sitting on a table with nobody in the room versus a gun in someone's hand, and whether the gun is actually held down or it's being pointed. There's a difference of understanding, is this gun on the person, and that person happens to be a security guard, versus is this a student, right? And being able to create that level of detail and discern the different scenarios and then create different kind of risk ratios based on what the policies might be for a business is where we spend a lot of our time really fine-tuning the system. And for every environment, it can change. If we're putting our solution into, say, a casino, we've got a lot of electromagnetic things that are going on between slot machines, sliding doors, these kinds of things that can create interference, and be able to almost dial up and down what's the degree of true positives versus false positives for this environment, and really tuning that environment. So there's a couple of answers to your question there, but you're correct about that level of kind of advanced knowledge that we can provide. First off, depending on the environment, we do have to go in and tune it, right? And we can do that within that environment. We have, databases of insights that we've gained from being in multiple different locations that will provide certain baselines in terms of what is normal behavior and what is abnormal behavior. But for different environments, we have to go tune the system. And it's a learning system. So over time, it gets smarter. We might work with some company that says, okay, it's Las Vegas, and if somebody's wearing a parka in the middle of the summer, that's a behavior that's not allowed. And so you have to start tuning the systems to watch for those kinds of anomalies, or anomalies like, certain patterns of traffic of people and things like that. But over time, the systems become smarter and smarter and smarter. We use different ML engines, but we have to almost point them as to what we want to look for first, so you can then intelligently learn. A school is different than a casino, which is different than an airport, which is different than a bank. But we have baseline insights from being in those different environments that we start with and then fine tune for each environment.
So if I'm understanding correctly, because I know that we've evaluated a number of computer vision oriented types of startups, and in some cases, I know there's a autonomous vehicle startup that's really taking in real time traffic video feeds to train their system. So in a sense, the CCTV feeds that you guys have collected over the years is really the training ground as well as the live feeds that you guys are getting, and then tuning
Yeah.
for that. And I think one thing that I wanted to kind of call out is for those that are listening, it's one thing to do, like you said, facial recognition on an individual subject, putting filters on an individual subject. But what we're talking about is a public space and a large audience of people with movements.
Yes.
So to be able to actually do multiple instances and be able to have multiple classification going at the same time, that's actually quite both difficult, but also computationally intensive as well. Can you talk about the notion and what is a tolerance in terms of capability to actually do true concurrent analysis? So let's say a stadium, for instance. So a particular angle or view looking at anywhere from several hundred to 1,000. How many instances of issues or detection could your system actually be able to identify in real time?
Yeah, it really depends on, again, the environment. It's hard to sort of get it depends answer, but a sports stadium with 80,000 individuals in it and amount of traffic that goes on there versus, say, an entrance to a school, right, where you've got 4 or 5 kids coming in every couple of minutes, right? Very, very different environments. And so, it really comes down to then how you engineer the environments. Do you have enough camera views? What kind of cameras are you using? What kind of environmental conditions? If you're looking at an outdoor baseball stadium, for example, and you've got a lot of cameras, but all of a sudden the lighting changes in the evening because you're playing a night game, and these are all things that we have to take into consideration. So it's important for us to spend quite a bit of time up front with the customer running pilots, again, to dial in and fine tune the system. It's not simply a cookie cutter that one size fits all, which is why it's a bit of a complex solution to bring to market. Excuse me, to answer your question more specifically, the kinds of, rates of performance we're seeing when we got things dialed in correctly, or dialed in correctly, is, we'll see north of kind of, 95% true positive rates, again, depending on how we dial it in. In terms of what it takes to kind of, and how much capacity we can support, depending on what we're looking for, and how many cameras and what we're looking for within those cameras, you'll start to stack up. We typically operate on-prem, so we have real-time response rates. So things are detected within a second to a second and a half maximum, right? And we sort of set that as our SLA of performance. And then from there, we'll engineer the number of cameras, the number of servers, and things like that.
So I want to transition the conversation a little bit differently to things that are more biological or chemical based. So there are startups and solution providers that are providing a physical system, but it still requires for them to essentially take a sample, whether it's a cotton swab or maybe it's essentially some molecules, and have to go through a certain test. And I think the startup that we've seen that is most promising is they're able to take maybe half an hour, 45-minute analysis down to maybe 5 minutes. Tell us about your ability to handle biological, bacterial, but also chemical types of issues that could come up.
Yeah, well, at this point, Scott, we have not fully kind of deployed any solutions that are looking at biological. We're partnering with various other companies to integrate that into our platform. But we're still very, very early stages. So I'm going to confess at this point, I don't really have much to kind of add to the kind of the conversation around kind of biological things like that. We're more looking at kind of behaviors and situations and, image recognition. But partnering with others, we're starting to talk about, okay, how can we do things like, watch for or detect airborne viruses and things like that, and just have that as another source of data into our platform.
Now, others are certainly, I think, within even the kind of thermal and temperature range. Some there's a lot of different solutions that are out there, but from the reflection of light on the skin temperature to being able to detect the temperature, to even listening into sound and acoustic level. So in other words, if somebody is about to rob a bank, their heart is likely to be palpitating. Their temperature may be slightly elevated, for instance, aside from kind of physical jittery movements, for instance. What are you getting at in terms of potential additional modalities that could look into the biological, physiological aspects of somebody? Again, you can't get into the galvanic skin response, but a little bit of X-ray, so to speak.
Yeah, the good news here is what we're seeing is more and more capabilities actually at the end devices. So if you look at what's happening with a lot of the camera companies and other folks doing other sensing devices, they're starting to create that intelligence at the edge that we can take advantage of. In our case, we're not actually looking to replicate the knowledge that they can create through that analysis. We're actually looking to take advantage of it and correlate it. So if I can start to look at things like, okay, here's a gentleman with an elevated heart rate who's also wearing a hoodie, right? And now our magnometers are actually detecting there's an excessive amount of metal on him and it's not an umbrella, right? You now start to correlate that to provide that higher degree of accuracy that this is a risk. Somebody could have an elevated heart rate because they just ran a mile when they went to the bank, right? And so, so you've got to, I think that's where the multi-sensor kind of approach actually allows you that higher degree of accuracy and lower amounts of false positives. So we're actually, in those cases, taking advantage of readily available technologies off the shelf and using that as another source of data into our AI engines, and then capturing all that information into the data lake that gives us a much a broad set of baseline information that we can then use to actually make decisions against.
Understood. I think that makes a lot of sense. Now, when you guys are deploying your solutions, I got to imagine that as part of that, you guys have also a set of recommendations. So you're looking at the kinds of CCTV camera and hardware and making sure that the hardware is actually minimally providing the kind of data that you need. Is that true, or are you guys basically plug it into any hardware at this point?
Yeah, there's certain minimum standards that we're looking for in terms of like IP cameras and things like that. But the good news is that there's a broad set of providers out there. Whether it's Access or Hanwha or any of the other providers, there's a lot of providers who are really advancing the art of IP at the edge, right, and AI at the edge. And so we don't have a particular bias to a particular camera right now. We're multi-vendor, right? Just like we're multi-vendor in terms of other sensing devices. So long as we're partnering with one company right now that's doing some really interesting things in terms of access control with badges, and they're actually getting certain information off of that, which becomes another source of data for us in terms of watching for anomalous behaviors, right? And how do we then start to take action to feed back to some of their systems to perhaps lock down doors? So we see ourselves as the intelligence engine that can then use different sources of information, whether it's from various IP cameras or from other kinds of sensing devices. Whether that is detectors sitting in the ceiling that are watching for certain things like carbon monoxide. What does that mean? And so what actions would we need to take or to inform individuals on?
So let's real briefly talk a little bit about 2021 and kind of put our kind of forward-looking hats and start to opine in terms of crowd control, right? So let's just kind of look at the baseline of what we're looking at. So across the world, we have people in one way or another been in some sort of a lockdown mode, which means that they've been constrained in terms of their ability to travel and so forth. And of course, with that, there's a lot of kind of built up anxiety. In some cases, people have mental health issues as well, like depression and so forth. So when the floodgates open, whether that's after the vaccine or some level thereafter, we're going to start to see a pretty large crowd movement from a smart city perspective. And we know because we're looking at commodities like jet fuel pricing, we're looking at things like Airbnb's IPO and the reason for the pop in terms of its increase in share price. All of that is this notion of pent-up demand for tourism, pent-up demand for large outdoor venues, concerts, sports arenas, and so forth. So come 2021, at some point next year, we're going to have a lot of people going to a lot of different places. And their baseline is a big degree of frustration, anger, and of course, we've seen a big increase in domestic terrorism for various reasons of ideology. How does that kind of environment situate you guys, and where can you guys add the most value in terms of places?
Yeah, it's a great question, Scott. Thank you for that. It's been an interesting 2020 for us, and we're really looking forward to 2021. If you think about our initial value proposition and our initial offer set around protecting against threats from guns, weapons, and things like that. That obviously has its best application in places where crowds gather. Those who wish to, commit, acts against society are typically targeting the place where they can make the most impact. And that's things like schools, that is things like stadiums and unfortunate events, excuse me, like what happened in Las Vegas, with the shooting at the MGM. So 2020 has been, a pause as you point out, with people gathering. And so it's actually, caused our business to pause a little bit, but given us an opportunity to continue to invest in the platform to create a higher accuracy, but also look at different form factors for delivering. So right now we're working with a partner to deliver a solution that will serve the very large organizations who provide concerts and concert venues around the world, right? And they're actually looking, because these concert venues change quite frequently, can I create a mobile version of our product to actually go serve those environments? You think of things like the Texas State Fair, for example, where hundreds of thousands of people go to that environment for a 2-week period and then it disappears. So how do I create kind of mobile application to deliver the same sorts of things? You think about things like, schools that have a semester and then disappear, right? Or seasons for sports and things like that. So we've used the downtime to actually prepare our product to have many more form factors to be able to deliver out into the marketplace. We are currently, engaged in conversations with all those organizations. We're in trials with a majority of them in almost every vertical that you just mentioned, whether it's sports environments, shopping environments, school environments, stadiums and these sorts of things, because they're all in the process right now of preparing for the onrush of people who have that pent-up demand to return, but they want to return safely. So we kind of look at what our offer is, not only for the defense against things like weapons and attacks, but also the ability to do more things like perimeter security, to watch for potential fights, disturbances, behaviors, these sorts of things, theft, crime, all within the same package on the same platform, right? As a way that we can work with our customers so they can reestablish trust to their customers that it's safe to come back to the environment again, right? And, a lot of times people, like you think of COVID, have been reluctant to go to a certain environment because there's an unknown risk. If I go to this restaurant, is it following clean policies or not? Is the person in the next table beside me, suffering from COVID or not? How do I know? There's an unknown risk, an undetected risk there. With our solutions, you can actually allow those commercial environments to assure their customers that they filtered out that risk. They pre-seen it and prevented it from actually coming into the environment, so that they can now have a safe and enjoyable experience, right? And so, we're actually looking forward to 2021. We're already in conversations. I was with one this morning with a very large commercial real estate organization that's looking for all their employees to return back to the office at a time and have them assured that they feel safe.
And just to kind of caveat this a little bit is, if you're looking at temperature isn't necessarily definitive, sufficient data.
Yeah.
To indicate somebody is COVID positive. But really, there's other symptoms. But certainly, it's a screening filter, correct?
Yes, it's a screening filter, and it can at least, if you've got a very large crowd of individuals who are walking the gates of a baseball game, right? I can quickly determine out of this group of 1,000 people within a second, this is the one individual who's a potential concern, and then we work with the operations organizations to provide suggestions to them about here's potentially what your next steps are to, bring that person off to a side area, go through a secondary screening and things like that. And if there's a challenge, reject them. In conversations we've had with various, NFL organizations, for example, they are putting these kinds of policies in place so that as their clients return, right, their primary mandate is to protect the environment and protect all the paying clients. And if there's one who's going to put that whole operation at risk, they'd much rather have the insight so they can then drive a secondary, check with that individual and take the right corrective action. And that applies to whether it's a temperature in COVID or a gun or a weapon or, bad behaviors, and kind of stopping these things to create a safe environment for everybody.
It's interesting. As someone who travels pretty extensively before COVID, kind of learned over the years because of terrorist acts, whether it's in Paris or here in domestic, is that I've learned to kind of avoid certain, let's call it transportation arteries or hubs and
yes,
avoid crowds, because subconsciously just this concern of potential threat. So, it's not great to hear that there's a systematic approach to screening and filtering some of these things out. And with that, I've been joined by Peter Evans, who is the CEO of Patriot One Technologies. Thanks for joining today.
Thank you, Scott.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.